are simplifying radicals, and Swati's going to write down our two important things to keep in mind when we're simplifying just square roots, because we will go further into cube roots and things to the nth root.
Hold on. Switch.
Okay. So right now Swati is writing that you can only take the square root of a non-negative number. Okay. And if you see something, the square root of something that is a negative number, it's not a real number. And another important and helpful tip is try to remember your most common square roots.
Great. Wow, we love that handwriting.
Swati has written down our two most important facts, so keep this in mind when we give you some example problems in a few seconds, okay? Okay. So we put up some problems for you guys to try. Feel free to pause the video if you need to. Okay.
Okay, you do that side, I'll do this side.
Okay, so the first one we have here is the square root of 64. And just by knowing basic square roots, by memorizing your perfect squares, we know that the square root of 64 is actually 8, because 8 times 8 is 64. Okay. And our next one here, we have the square root of negative 81. Now, most of you might jump and think, oh, negative 9. But look at our first rule here. You can only take the square root of a non-negative number. And because we have a negative 81 being square rooted, this isn't possible. So it's not a real number. This is your answer, because you can't take the square root of a negative number. Okay? And this one here, you might think, oh, what is 49 divided by 81? I don't know. I can't do that without a calculator. But guess what? We can split this up into the square root of 49 over the square root of 81. And we know that by memorizing our perfect squares, that the square root of 49 equals 7, and the square root of 81 equals 9. And now this can't be reduced, so this is your final answer.
Okay, number 4, here we go. So we have a variable in here. So this might look kind of complicated, but don't worry, okay? So what we're gonna do, we gotta write this out. So since it's the square root, you gotta think about what multiplies times itself to get a to the 6th power. And a to the 3rd power times a to the 3rd power equals a to the 6th. And we know that because of exponent rules. When you multiply exponents with the same bases, you add the exponents. So this answer is a to the 3rd. Okay, here we go. So as we can see, in this, we have 81. And looking at number 3, we can see that 81 is a perfect square. So, because it's a decimal, we have to think about what multiplies times itself to get 0.081. And the answer is going to be 0.09.
Right. So here you have it. This is just basic simplifying radicals. We're going to go on to simplifying cubes now. Moving on from square roots, we are now at cube roots, and Swati is going to again write down our key points, which are, you can't take the square root of a negative number, but you can take the cube root of a negative number. Now that is because by taking the principle that if the cube root of a has to equal b only if b to the 3rd power equals a. Now when you take b to the 3rd power and you times it by, say, like -2. -2 times -2 is 4 times -2 is -8. So you can take the square root of a negative number. Now with our helpful hints and key things to remember, we are going to put up some examples. So we put up some example problems, and we're going to give you some time to look at them. Here we go. We are going to start with number 1, obviously. Now, the cube root of 64. And just like memorizing the perfect squares, it's also beneficial to memorize perfect cubes. Now, the cube root of 63 is actually
64.
The cube root of 64 is actually just 4. Because using this principle, 4 times 4 times 4, it ends up equaling 64. So we can use this to find our answer. There we go. Okay, now the next one here. See, we see a negative number, and you might think, oh no, this is not a real number. But it actually is, because you can take the cube root of a negative number. Okay, now taking this, the cube root of negative 8 is actually negative 2. And we can split this up, the a to the 4th, with a to the 3rd times a. And now a to the 3rd is just a. And then you keep the cube root of a in the radical because you cannot take the cube root of just a. And so I'm just going to do the next two.
Fantastic. Okay, so we have a similar situation to number 3 of last round, in which we have a fraction, and you might think it's going to be very difficult because it's a cube root. But don't worry, we're going to do the exact same thing we did to the other one. We can write it as the cube root of 27 over the cube root of 216. And if you memorize your cubes, you'll get 3 over 6. And still, we have to simplify it. So 1 over 2 is your answer. Wow. Okay. Next one.
Well done, Swati.
Thank you. Okay. So for this one, again, we're going to break it up just like we did with a. So we're going to write it as x to the 3rd times x. And this one is just y to the 3rd. So what we see here, we can cancel these out. So it'll go x, y, outside of the cube root. And then, looking for what we have left, we have x. So xy and the cube root of x is your final answer.
And we know that we can just cancel things like x to the 3rd, taking the cube root of it, because it's really just x times x times x, right? Okay. Next, we have nth roots, and you might be confused, what is an nth root? But really, if we just write it out, it's just using a variable for the root number, for the root index. So it's really just taking the nth root of a, which is any number. So that's basically all we need, and this has most of the same properties as all the other square roots and cube roots and stuff, okay? So we're going to put some example problems and, yeah.
Welcome back.
Okay, so we put up some questions and pause the video if you need to. So here we go, and you might be looking at some of these and you might know what to do, but you also might not know what to do, but we're going to explain it for you.
Fantastic. Okay, let's get started. Okay, here what we have is a -4 in a parentheses. So, when you think about this, first if you have a square in the radical, you need to simplify that first before you even think about canceling the radical or like solving it fully. So what we got to do, -4 times -4 is 16. So, this becomes root 16. And now, that's really easy. We all know that. It's 4. Okay, next problem. So, we see we have a x squared inside of a root. So, obviously, the answer is x. However, we don't really know what x is. So, in order to keep the answer positive, you put absolute value around it. So, the answer stays positive and it doesn't become not a real number.
Yeah, and we only need absolute value when we have an even index. So here, we just don't write the 2, but it really is the square root. But on an odd index, such as a cube root, you wouldn't need this because you would multiply it out. But here you do, because there is a potential for it to be an odd number.
Third problem, we have y plus 3 parentheses to the 4th power inside of a 4th root. Now, again, the answer seems obvious. Y plus 3. However, this is an expression that has a variable in it. So what we have to do is put absolute value around the expression to ensure that it stays positive.
And we do that because, again, the even index. Okay, now here on number 4, you might think and see, what is this? Do I have to factor it? What? How do I take the square root of this? Okay, but really, if we just look at this, and from our factoring videos, actually, I don't think, do we have factoring videos?
No, we don't.
Okay, well, from basic rules of factoring, we know that this is actually a perfect square, and it is x plus 2 times x plus 2, which can also be written as x plus 2 squared. So if we just put that in the radical, then we can cancel it out and it just equals x plus 2. And again, it's an even index, so we need to put absolute value signs to make sure it stays positive. Okay. Now this one, you can already see that it's probably going to be easy because it's just 36 and the square root of 36 is 6. And then again, like this one with the x squared, we just have another x squared, so we put an x. And since it is an even index and then a variable pulled out to the odd exponent, to the odd power, we have to put absolute value signs to make sure it's positive.
Great.
So there you have it. We did simplifying radicals. Hopefully it wasn't hard. Okay, it's rolling.
Wait, good day, ladies and gentlemen. We want states.
Stop eating in the background, Go-Go.
Yeah.
Alright, bro, we don't have to
Okay, bye now.